You've seen this before. You have a base and an exponent. The big number is the base, and the tiny little number up to the right-hand corner is the exponent. Let's look at these in a different case. Here I have some examples. 3 to the second times 3 to the third equals 3 to the fifth. 4 to the fourth power times 4 to the sixth power equals 4 to the 10th power. 7 times 7 to the 8th power equals 7 to the 9th power. Take a moment and see if you notice a pattern. Okay, let me see if I can make the pattern stand out a little more. 3 to the second, you know that as 3 times 3. And 3 to the third is 3 times 3 times 3. So altogether we have 1, 2, 3, 4, 5 threes. 4 to the 4 would be 4 times 4 times 4 times 4. And 4 to the 6 would be 4 times 4 times 4 times 4 times 4 times 4. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fours. 7. That's just 7. And remember, when there's not an exponent, it's understood to be the number 1. So 7 is really 7 to the first power. And that works for any number. 7 to the 8 is 7 times 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 7. And when we add them all up, oh, I gave it away. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. The trick, if you saw it, was if I take my exponents, I can add them when I multiply. So 2 plus 3 is 5. Now this only works when the bases match. Both of my bases are 3. Both of my bases here are 4, so I can do 4 plus 6, which is 10. Let's move on. Let's look at this one. 3 to the 7th power divided by 3 to the 2nd power equals 3 to the 5th power. 4 to the 4th power divided by 4 to the 3rd power equals 4 to the 1st power. 7 to the 8th power divided by 7 to the 3rd power equals 7 to the 5th power. Let's see if you notice the pattern. Now this one you might have gotten the pattern a little bit quicker because you know the pattern for multiplication. But just in case, let me show you what this really means. 3 to the 7th is 3 times 3 times 3 times 3 times 3 times 3 times 3. It means we have 7 threes divided by 3 to the 2nd. So 3 times 3. 1 3 cancels out of 3. 1 3 cancels out of 3. I am left with 1, 2, 3, 4, 5 threes. Let's look at the next one. 4 to the 4th. 1, 2, 3, 4. Because 4 to the 4th means 4 fours multiplied together, not 4 times 4. 4 times 4 times 4 times 4. Okay? Divided by 4 to the 3rd. And exponents, remember, the operation is always multiply. Okay? Cancel, cancel, cancel. I am left with 1 4. So I could have written this as 4 to the 1st power or just plain 4. But I wanted you to see what it looks like with an exponent. And the last one, 1, 2, 3, 4, 5, 6, 7, 8. Because I have 8 7s. Divided by 7 to the 3rd. Let's cancel. And it doesn't matter which ones you cancel. I just did a random order. I have 1, 2, 3, 4, 5 7s left. Did you notice the pattern? If you said subtraction, you're correct. When the bases match, remember the bases have to match, I subtract the exponents when I divide. So 7 minus 2 gives me 5. 3 to the 7th divided by 3 to the 2nd is 3 to the 5th. 4 minus 3 is 1. 4 to the 4th divided by 4 to the 3rd equals 4 to the 1st. 8 minus 3 is 5. 7 to the 8th divided by 7 to the 3rd equals 7 to the 5th. One more law. 3 to the second raised to the third power is 3 to the sixth. Let's look at this. This 3 says that I want this parenthesis 3 times. So 3 to the second, 3 to the second, 3 to the second. And if we go back to the first law we learned, when you multiply, you do what with the exponents? You add them. So 2 plus 2 plus 2 is 6. 3 to the sixth. Okay? 4 to the fourth to the second power is 4 to the fourth times 4 to the fourth. Again, we're multiplying, so we take our exponents and add them, and that's why we got 4 to the eighth. This one would be 7 to the fifth times 7 to the fifth times 7 to the fifth, because it says I want it 3 times. 5 plus 5 plus 5 is 15. Take a moment, look at the patterns, and see if you can come up with another way that I could have done this instead of writing it all out. If you said multiply, you're correct. 2 times 3 is 6. 4 times 2 is 8. 5 times 3 is 15. This only works when you have an exponent, parenthesis, and another exponent, when you have exponents in a row. I hope you learned a lot about laws of exponents today. Good luck trying your problems.